Hey everyone, this is Siri and I'm back with another Pytorch video, and this is going to be on datasets and DataLoaders. Okay, and the code that I'm going to write here is part of a Pytorch tutorial, and it's really good. I would definitely recommend checking it out, but I'm going to be talking through it and just see what every line of code does and just see how it all works. Okay, so we're going to be talking about datasets and data loaders. So in Pytorch, you can use preloaded datasets, or you could use your own, like using these two data primitives, datasets and data loaders. And in this video, we're going to be using FashionMNIST. We could have also used Safar. We could have used Flickr. We could have used fake data or like something from Torch Audio. But here we're just going to be using FashionMNIST. And by the way, Pytorch has tons of preloaded data sets, so we can you can experiment with them and just see the different images, the different audio, and I think it's really cool to check out. So, okay, datasets and data loaders. So let's just first talk about FashionMNIST, just some background information. It's a 28 by 28 grayscale image. Well, images. It's a data set, right? So we're gonna have 28 by 28 grayscale images, and there are gonna be 10 classes in total. So whenever we classify like an image from the fashion data set, it's gonna be one of 10 different types of images. So, and another important note is that all data sets, whether they're preloaded or whether you create them yourself, they're all going to be subclasses of torch.util.data.dataset. Okay, and each of these, or like any of these data sets, can be passed into a data loader. And we're gonna be talking about that in just a moment. Okay, can be passed into a data loader. Okay, any Pytorch data set. Okay. Great. So let's do our standard imports. Okay, we're going to import Torch. We're going to import, like we said before, torch.utils. Sorry. Okay. Okay, and these data sets that I'm importing are the ones that I've mentioned before, right? Like the FashionMNIST, the Safar, and the other data sets. And any data set is a subclass of this capital D data set. Okay. Let's import Torch Vision .transforms, and we're going to import tensor, okay, because we need to apply some transformations on them and convert that image to a tensor, so our model can actually process it and do some analysis. And last but not least, we're gonna import matplotlib.pyplot. And this is just for our visualization and just to see what's going on with our model, what's going on with the data set. So we can have like a visual representation. That's an important part of machine learning, like visualizing your data and whatnot. Okay, so those are our imports. Transforms. Okay, great. So let's create our training data. Okay, let's create a variable called training data. And from our data sets that we just imported, we imported this from Torch Vision. It's going to be the FashionMNIST. And they're going to be taking a few parameters, right? It's going to be taking the parameters root, train, download, and transform. Okay, and let's save this to data. Okay, it doesn't yet exist, but that's what our download is going to be there for. So if we don't have it, it's going to download this training data. And we all have training data, and we also have test data. So this tells Pytorch whether this is going to be training or test, and let's set train equal to true. And let's set transform equal to tensor. Okay. And let's create our test data. Same format. So if you wanted to do another data set, you could have put that there. The root is also going to be data. Train is going to be false because we're going to make this our test data. Let's set download equal to true. We want to download it. Okay, and transform equal to tensor. Okay, and let's download that. Okay, and we see it downloading. Okay, great, done. Okay, so we have that downloaded. Let's iterate and visualize our data. And by iterate, I mean like take a few batches and really go through our data so it can train and learn, right? That's the whole point of these models, is to learn and be able to make accurate predictions after training. So let's iterate. We're not going to do the training right now, but we're just going to iterate and visualize it. Iterate through and visualize it. And we're going to iterate through using our data loader. Okay, so that's what we're going to do right now. And one quick thing I want to show you here is that you can actually extract a few images manually like you would a Python list using indices and using the brackets. So let's create like our classes. So our 10 classes for our fashion data set, FashionMNIST, this is a dictionary, right? We're going to have key value pairs. Okay, and this is going to be a t-shirt. There are going to be 10 of them. Okay, the next one's going to be trouser, pullover, Okay. Dress, coat, sandal, shirt, sneaker, a bag, and an ankle boot. Okay, and it goes to 9 because we started at 0. And this is a dictionary of our 10 classes. They're also our image labels. And so let's plot this, right? Let's see what a few of these images look like. Let's create a random index and let's go through it, right? I said we can index it like we would a Python list. So let's say that figure is equal to plt.figure, okay, of size 8, 8. Okay, that's going to be our fig size. And this is all matplotlib. Okay, I would definitely recommend getting familiar with it. Okay, so here we're creating an 8 by 8 plot. Okay, our columns and rows, let's make it 3, 3. Okay, so there are going to be 3 columns, 3 rows. And let's go through like our plot, right? So we have 3 rows and 3 columns, and we're going to go through each of them, right? Because this is the area, and we're going to go through each and individual one. And the reason we have +1 here is because these parentheses make it exclusive. So if you want to get through all of the images, you need to add a +1. Okay, and we're going to make a sample index. Okay, torch.randint. Okay, len. This is going to be the length of our training data that we defined up here. Okay, our training data. And the size is going to be 1, comma, and that's kind of implied when I just leave the second one blank, right? Okay, and we're gonna take .item. Okay, and our image and label, it's gonna be training data, and this is what I meant when I said you can take indices like this. Sample index. This is gonna be random, right? Because we said randint. So this is one of our factory methods, and so this is going to be picking up a random index out of our training data. And because this is two-dimensional, this is a two-dimensional tensor, and we're picking up the item out of it, so we're setting image comma label equal to that image comma label. You see how I just didn't say 1, but I said 2 variables here. It's because of what we did here with the torch.randint. And let's add a subplot. Rows, columns, and our I from our for loop. And plt.title, this is going to be the title of our plot. Classes, you see the dictionary that we defined on the top, and we're going to be picking out each of these labels. Okay, so it's a title, and the axis is going to be off. we didn't need this I am show since we're doing it in Jupyter Notebook. And this is our color map, the C map. You can choose any color you want. You can do like RBG, you can do like all of those kind of fancy ones. You can see a list on Matplotlib. But since these are grayscale images, we can make it gray. Okay. And let's do plt.show. Okay, so I forgot the commas everywhere. Okay, so when you run this, size equals, what is with me today? Okay, so we have our images. Okay, these are random. We're not going to get each and every class. So we have a few ankle boots here. We have a sneaker. We have 2 pullovers. We have a t-shirt. And this is just to visualize what our data looks like. If we said RBG, RGB. Okay, here are the possible values. Okay, let's just pick one. Let's say bone R. So this is just a visualization. This isn't the main point of this video. But let's get on to creating our custom dataset for our files. Okay, creating custom dataset. Okay, and the dataset class has 3 important methods. Okay, one of them is a constructor. It's going to be our init, and there's also a len and a get item. So if we create our custom dataset, we're going to need to overload these methods and use like a double underscore. And so let's see that. Okay, in action. Import OS, import pandas as PD. Pandas is great if you have like tabular data, and it's also great in dealing with our labels. So, okay, and let's also import torchvision.io. From torchvision.io, let's import read image, and that's gonna be good for turning stuff into tensors. Okay, so let's create a custom class, custom image dataset. You can call it whatever you want, depending on your dataset. Like if you had a dataset of like animals, you could call it class animals dataset, but I'm just going to be calling it custom image dataset. And like I mentioned before, it's a child class of dataset. It's a child class of this this data set here. Okay, and let's have our init. It's gonna be our constructor. We have self. We have annotations files. File. Image directory. Transform. Target transform. Okay, so the labels are going to be stored in a CSV file, which is the annotations file, and our images are going to be stored in this directory, and transform and target transform are going to be set to default values of none. You can input them as your arguments, but just in case you don't, it's not going to throw an error because we're setting the default value to none. Okay. So self.image labels is going to be equal to pd.read CSV. Okay, and our annotations file. Okay, so we're defining this instance variable here. So self.image directory is going to be equal to the one we pass in. Okay. Self.transform is equal to transform. Self.target transform is equal to target transform. Okay, and let's define another function that we need to define in order for it to be considered a dataset in Pytorch. We're going to need to define this len. Once again, it's overloaded, so we can we can write whatever variables we want down here. So we're going to return len of self.image labels. Okay, so it's going to be the number of images you have. Okay, and the one last one is going to be def get item. Okay, and what this does is that it gets a random image from your data set at a specific index. So let index be another parameter of this function. And let's set our image path equal to os.path.join self.image directory. Okay, self.image labels.iloc. And this is from pandas, you guys. Okay. So this is just like slicing in pandas. So yeah. So what this does is that it identifies an image's location. And image is going to be equal to read image and then image path. Remember we imported something up here. We imported read image right here. Okay, from import torchvision.io import read image. Okay, and that's why we needed to define our path here so that we could pass that in as an argument so that we can convert this image to a tensor. Okay, so that's the purpose of this getItem function. We can also set a label equal to our self.image labels. iloc. Next, column 1. Okay, and these are the rows and columns. So Okay. And also remember how we set this equal to none as a default? Well, if it's not none, right? If transform is true, right? Like in Python, none is going to be false or 0. So if it's true, and if the person actually like inputs in an actual transformation, we can apply it. So we can say image is equal to the same image except it's transformed now. Okay. And so if self dot target transform is true, then we'll do the same, except it's gonna be the label. That's what target means, right? It's gonna be the output, or like the actual answer. So label is equal to self dot target transform label. Okay, and last but not least, we're going to return the image and its label. And this is a these are the 3 functions that you need. One of them is a constructor, len, and get item. Okay, great. Now the last thing we're going to do is actually put this into the data loader and prepare it for training. So the data set is going to get our features and our items like one image at a time. And what is usually done in deep learning is we do it in batches. So we need another iterator, which is the data loader, that can satisfy these requirements that a simple for loop can't. And these requirements are to pass the samples as mini batches. Okay. And we also need to shuffle the batches. Okay. And we do this to minimize overfitting, which is just when it trains to the data so much that it can't really generalize it, and it just it almost memorizes it instead of generalizing. So the last thing is to use multiprocessing, and the reason we need this is so that we can do it parallelly. On like multiple processors. And this is just so that it makes it go faster, because there's a lot of computations and it'll take a while. So okay, so our data loader is an iterable. And let's do some more imports from torch.utils.data import data loader. Okay, let's create a training data loader and a testing data loader. Okay. And yeah, we're going to create a data loader object. Okay, training data. We're going to pass in our training data. We're going to say our batch size. We're going to set it to equal to 64. So there's going to be 64 features and labels. Okay, so, and also we want to shuffle it. So you can say shuffle equals true. And let's do the same thing here. Let me just copy paste it. And instead of training data, it's going to be test data. Okay. Okay, great. Okay, this is tuple packing or unpacking. So just makes things a little easier. Okay, and this next here, we usually see with generators, right? So if you recall, a generator, it doesn't give you all the values at once, right? You need to call next on it so that you can like save space if you don't really need all the values at once. So that's what the next does here. And let's print the features batch shape. Okay, let's do an F string. Okay, train features dot size. Okay, we're printing out the shape, so okay, let's do the same with our labels. And remember, the labels were just like the t-shirt, the pullover, the ankle boot, and like all those things. Label batch shape. Okay, train label size. And let's do some plotting. Okay, let's see what this looks like. So image train features 0.squeeze, and we'll talk about squeeze and unsqueeze in another video. It's pretty important actually. And let's set label equal to train labels. Okay, our training labels. 0 plt dot I am show. We're gonna say the image, and then our color map's gonna be gray. Okay, and let's check it out. Okay, so print label okay. Yeah, I think I used classes instead. Train. Oh, okay. Oh my goodness. Okay. Train labels. Okay, and so we see an image of something. Okay, label 3. So address. Okay, it looks like it somewhat. Okay, but yeah, I think that's it for this video. We talked about datasets and data loaders. We used the FashionMNIST dataset as an example. We did a lot of imports. We now know about dataset and then lowercase datasets, which we can use. And if we wanted to have our own datasets, which is pretty often, right? So we can create our own custom dataset for that using a few of these overloaded methods, using the init, the len, and the get item. And we talked about what data loaders were and why we need them, what advantages they have, and how it's an iterable. And we just did some visualization here and there. Okay, great. I think that's it for this video. I hope you learned something. And yeah, like, comment, and subscribe, and have fun. Thank you.